Okay, example number 1. The double web girder is constructed from two plywood sheets that are secured to wood members at the top and the bottom. So we know that these are known as your plywood sheets. And over here, you have top and bottom members. And they are made of wood. Okay, these are all your plywood sheets. Okay. Now, interesting in what information they are giving us. Okay, the allowable bending stress for the wood, so stress allowable, is equal to 8,000 psi. Okay, and the shear stress allowable is equal to 3,000 psi. Right? They give us both the normal stress and the shearing stress. Okay. And they told us that the spacing of the fastener is which is S is equal to 6 inches, and each fastener or force resistance, or what do I call it? I call it earlier fastener resistance force. Fastener resistance force, okay, is equal to 600 pounds for single shear configuration. So there are a lot of things that we have to recap over here. Okay, so we are given quite a bit of information over here. Okay, so there are a few modes of failure. Okay, so what are the possible? So let's look at different failure mode. Okay, so the thing about this analysis is you have to view different modes of failure. Okay, so what do I mean by that? Okay, so they give us 3 different values. Okay, so we are going to determine failure mode number 1. Okay, which is failure at the joints. So failure at the joints, okay, which is failure over here. Okay, so this is failure at joints, failure at the joints, failure at joints, failure at joints. Now the failure at the joints is a very interesting term over here. Okay, so what do I mean by that? Right. So the formula that we can relate is Q is equal to VQ over I, and this is equal to fastener resistance force divided by spacing. Okay, fastener resistance force. So we were given that the fastener resistance force is 600 pounds. I'm going to talk about this. And they did highlight to us a single shear, as you see earlier. And we know that the spacing is what? 6 inches. Okay. Now, what I want to highlight is how do they get this value? Because only if you understand how they get this value, then you know what it means. Okay, so first we want to see how they get this value, and the next thing that I want to revise with all of you is what do we mean by single shear. You can see down here, hey, why this term single shear appears. Okay, what does it actually mean? Okay, so let me talk about fastener resistance force first. Okay, so let's look at fastener resistance force. So this is determined experimentally. Okay, and we know the resistance force is dependent on the length of the screw, length and diameter. Okay, length and diameter of the fastener. Okay, of the fastener. So what happened is, if what they do is, we have, for example, for this case, the fastener is a nail. Okay, for example, I'm going to draw the nail. So we have a nail. Okay, and this nail has been hammered into a member. So this nail goes into a member. Okay, goes into a member. Okay, it's nailed into a member. And this is the cross section. So what they do is they will apply a force. Okay, they apply a force or increasing force is applied till or until the nail starts to move. And some of you might say, Eugene, the force you're applying, right? The force that I'm drawing in red now, right? The force I'm applying is normal to the surface of the head of the nail. And then why is this? The question is, if this is normal, why, right? Why is this the shearing force, right? Or why is this the resistance force? Or sorry, wrong question. Why do we analyze shear, right? When the increasing force is perpendicular to the surface. Okay, we ask ourselves this. So if we look into the other side of the nail, so if we look into this part of the nail, okay, and sorry, I will. If we look into this part of the nail, and if I were to put an element down here, okay, if I put an element, and if I were to increase the size of the element now, right, this is the size of the element, right, and because the element, right, the nail will want to have, so this is the direction of the motion, right, that is the direction of the motion of the nail because we are pulling from left to right. We know that we are going to have a resistance. So if I were to draw my configuration over here, this is my Y, this is my Z, this is our rotation of X. So we know that we have a resistance. Here we know we know that we have a shearing stress acting in this way, right? It will resist the motion, right? So this is shear, and this is intersecting plane is Y, and this is Z. Okay, so now over here is shear Z, Y. Okay, so because of this shear stress is resisting the what? Increasing force or making the nail stay. Okay, so that is why we look in the shearing configuration. That's why when pulling our nails, no doubt we pull out this way, the force actually applied, the resistance is actually what? Parallel to the surface, which is known as shearing stress. Okay, so that's the first thing. That's why for fastener, we look at shearing stress and not normal stress. No doubt the force that is applied that I drew in red, right, is normal to the surface, yes or no, the head of the screw, right? But we are the resistance force, okay, or the resistance stress is parallel to the surface on the nail that is over here. Okay, number one. Second thing is, what do we mean by single shear and double shear? Okay, so let's look at the next thing is what is single shear. So this is just a revision for you. Okay, so what is the difference? So single shear, yeah, I'm going to draw single shear. So if we have plates, yeah, if we have two plates, or I'm going to draw fastener. So this is our fastener. Okay, this is our fastener. And then we have one plate over here. And then we have the other plate over here. And this is member number one. This is member number two. We know, okay, we know that failure, if this thing were to fail, failure will shear the bolt exactly or the fastener exactly where I put my red line. Okay, so that is where the failure region is. Okay, so this is our failure region. So when that's the case, okay, when that's the case, the shear stress is equal to, so if we have loads, so this is our P, and over here, this is P prime, right? So we know the shear stress is equal to P over A, where area is the cross-sectional area of the fastener. Okay, we know that. So this is what we call by single shear configuration. If it's a double shear, okay, again, I'm going to draw our bolt or our fastener.